Alright, hello everyone. It's May the 10th. Alright, we have to see if it's gonna work. I mean, for one, I don't have my pen and pencil, so I have to do this entirely on my mind. Will be interesting. Alright, let's take a look what we have today. I mean, yesterday was bad. Yesterday was also difficult, and yeah, but it's alright. I mean, this type of things happen. Minimum equals sum of two arrays after replacing zeros. Man, but I really do need paper and pen. Oh. Okay, I have some paper. I need a pen. I got a pencil. And I have a little piece of paper and I have pencil. That should be good enough. Minimum equals sum of two arrays after replacing zeros. So we have num1, num2 consisting of positive integers. You have to replace all the zeros in both arrays with strictly positive integers such that the sum of elements of both arrays becomes equal. Return the minimum equals sum you can obtain, or -1 if it's not possible. So what we have is, but hold a second, let me maximize this. Yep. So example, num1 3 2 0 1 0. Num2 is 6 5 0. So we want to replace all the zeros. So the sum of the first is equal to the sum of the second. Wait, hold a second. You have to replace all the zeros in both arrays with strictly positive integers. So in this example, the first one gets replaced with 2 and 4, and the second one with 1, and the total sum is, that's a 6, that's 12, and that's also 12. Got it. The sum of them. Alright, so first things first, what's the current sum? So 32010, the current sum is 6, and we have 2 opportunities. The second one is 11, and we have 1 opportunity. Right? Then we have 2 opportunities. So trying to see what will be the smallest that they have to be equal, and the max value we can take is really big, 10 to the 6. Okay. So of course, if we have a large value, it's simple to do, right? Simple to do. So typically one will be larger than the other, and one will be larger than the other, and you can always split them up, right? Depending on how many you have, you can always split them up. So in this case, we have one is 11, the other is 6, okay? And we can actually find the minimum that each one can get. So for the first array, the minimum we can get is 8. The second one, the minimum we can get is 12. So we will try we'll try 12, right? We'll try 12, and when we try 12, what we need to do is do 12 minus 6, right? 12 minus 6 is 6, and that is larger than the number of zeros in num1, which means we can do it. The case that it won't work is when we get the smallest, so the smallest on one array will definitely be more than the smallest on the other array. So we start from that smallest, right? And then we use that smallest. We say if that is possible, then for the other array, what's the amount that we need to add? If that amount is larger or equal to the number of zeros, that means there's always a way to do it. Otherwise, it's not. I think you can probably do this in the second one. So in the second one, num1 is 4. right? Current is 4. Num2 current is 5, and there's no more room to go. So the maximum, actually in this case it's not really maximum, right? Because the maximum is, you know what, there is a maximum. The maximum is actually this one because we have 4, 5, and 6, so maximum is 6. And the second one, the current is 5, so 6 minus 5 is 1. So we need the second one to have at least 1 0 in order to fit, but we don't have 1 0, so this is not possible. All right, it's not possible. And if you increase even more, then we actually require the hold on, let me think one more time. So yeah, so you have certain amount you need the first to get, but if the first one is is it too many or too no, it's too many, right? So you need to get 5. Let's say you need to get 5, and the first one has the first one has too many. Yeah, that's the thing. Too many. If I have too many zeros, it's not too little. It's too many zeros. If you have too many zeros, that means because they all have to be non-negative, so you have to set them to be 1, and then they will add up more than what you want, right? Yeah. So yeah, so basically I have 2 ways to go. You either pick number 1 to be the smallest, or number 2 to be the smallest. So in this case, if number 1 is the smallest, what we get is 8, right? But number 2 is already larger than 8, so that's not possible. 8 is not possible. And you can go number 2, which is 12, right? Which is 12, and we are 6, right? We have 6. We need to fill in 6. As long as we have smaller or equal to 6, we're good. If we have more than 6, then we are bad, right? In this case, for here, we get 6, right? Smallest is 6, but it doesn't work because we have 0, we have nothing to give. Now that's actually different. If we have 1 of this, and it will work, right? I have 1 of this, it will actually work. It doesn't work because it doesn't have anything. So it has to be, it doesn't have any zeros, and that's like a special case, right? So either you're too many, right? So or you're too little, a 0, right? 0 or you have too many. Neither works. But as long as you have some, then that will work. In this case, it's 5, right? 5, and this is 4, right? So we have 1. Need to add 1. So this one need to have at most 1. But this one has 2, so that's why it's not possible. But it can keep increasing, right? So like if it doesn't work, then we can increasing. But if we're increasing, that's the same as we do from the other side. So I think we just need to do from both sides, and it shall work. All right, let's give this a shot. Yeah, I don't think we did anything yesterday. No, I basically copy. That is not right, because it should be 10. And I think I should remove the other one. Because we did not really do anything. All right, so long. So we need to read through first and get how many of the current. So we have a, let's call it long S1, S2, okay, and we have int count. Let's count 0, 1, count 0, 2. Okay, maybe I can get my strategy out first. Find the sum, current sum of nums1 and nums2, as well as the count of zeros in both arrays. Right. Suppose one of the array, suppose filling all the zeros with 1 in one of the, in array 1, in nums1, creates the min sum. We check if this sum is reachable from by nums2, right? Similarly, we do the same same with nums2, right? If one of them, if neither is reachable, then we'll return -1. Otherwise, we will return the minimum sum of either scenario. So we'll say for n of nums1, right? So s1 will plus equal to n. Probably need to long this thing. And count 1 plus equal to n equal to 0. And now we'll do the same for nums2. S2 and then c2 plus equal to n equal to 0, right? So once we're done with that, then we can say choose nums1 as the base for min sum, right? So what we have is long min sum, right, equal to s1 plus long. Why don't you just long this thing? And if you long this thing, why don't we just keep going with this, right? Then we don't have to do this. So s1 plus c1, okay? And then what we need to do is to check if it's possible, right? So call it min sum 1. If min sum 1 minus s2, right, is the amount we need to get. And if the amount we need to get is larger or equal to number of zeros, and the number of zeros equal to 0, that's a special case, right? That's a special case. Okay, so if this minus s, special case first, if c2 is equal to 0, which means we don't have any 0, and so we don't have any 0, and the min sum 1 is not equal to s2, right? So it's not equal to s2, because you do a min sum on this and then you try s2, and then S2 doesn't equal to, because you really cannot do anything. So that's a case. Or, so this is C2 is not equal to 0. Then we can say min sum 1 minus S2, right? Minus S2, it's the amount that we need to achieve if that is smaller than C2, right? So we have too many, right? Just in these two cases, it does not work, right? It does not work. So we need to assign min sum 1 shall equal to long max, right? And then we also say choose nums2 as the base for min sum. So we can say long min sum 2 is equal to S2 plus C2, right? Again, if C1 is equal to 0 and min sum 2 is not equal to S1, or min sum 2 minus S1 is smaller than C1, right? So again, the same problem, it doesn't have enough. And then we can say min sum 2 is equal to long max, okay? And then we can say long rest shall equal to std, the minimum of min sum 1 and min sum 2, right? We say return rest is equal to long max, that will be -1, otherwise we'll return rest. Okay, let's see if this one, this is more like, I would say it's pretty much greedy, right? It's like a greedy approach, but we can just give it a shot, see if it works. So it works for these two test cases. I might want to try something more. I don't know. I mean, I put some random numbers in there. And oh, I need to put some zeros in there. I think if 2 little zeros. Zeros are quite important. All right, try it. Is not a valid. I think I have a trailing stuff. Okay. Yeah, looks all right. Let's try it. Well, I guess that is a solution. Pretty much greedy. See, these questions are handleable. They're very different in complexity compared to yesterday. Right? Yesterday was just so hard, and I kind of got annoyed, to be honest. All right, let's check the tutorial. Classified discussion. Let this be the sum of nums1, nums2, respectively. 0, 1, 0, 2 with the number of zeros. The minimum sum that the two arrays can reach is this of this. And there is at least 1 0 in both arrays. A solution always exists. That is true. And the minimum possible is this. However, if there are no zeros in one of the array and the minimum sum of them exceeds the fixed numbers, so yes. I think it's even simpler than how I do it. Right? It's even simpler than how I do it. You get all that, and then we say 0, 1. Yeah, this is larger than this, right? So either this is larger than this or this is larger than this. So if this is larger than this, and then you don't have zeros in this, or the other way, otherwise you just do, yep, that's pretty much it. All right, that'll be it. Happy vacation to me. I'll see you guys tomorrow. No. I think tomorrow night I'll be at the sea, so I will not be seeing you.